Guys, welcome to another set of notes on conic sections. Today we're going to look at a hyperbola. So like the other three conic sections that we have studied so far in chapter 10, we can define a hyperbola as a locus of points. The hyperbola is the opposite of an ellipse because the definition of an ellipse is the sum of the distances to the two foci is a constant. Well, in a hyperbola, it is the difference of the distances. The absolute value of the differences that is constant. So a hyperbola is the set of points P in a plane such that the absolute value of the difference between the distances from P to two fixed points, F1 and F2, is a constant 2a. That is the absolute value of the segment PF1 minus the segment PF2 is equal to 2a, where 2a is less than the distance between the two foci, F1 and F2. So some vocabulary real quick. The focus of a hyperbola is the fixed point F, and the vertices of a hyperbola is the intersections of the segment between F1 and F2 and the hyperbola. Okay, those are your vertices. And then the transverse axis is the segment joining the vertices, and this distance is 2a. So it's a straight line between the two. All right, let's go watch a video real quick on a little bit more in-depth look at how hyperbolas work.
Alright guys, as promised, here's a nice interactive kind of way to show that definition of a hyperbola so you can see what everything looks like and what's going on. Okay, so if you notice, I can move this up and down as these vertices get closer to the focus or foci. The hyperbola gets more and more narrow, and I can't really move it. It's a vertical one. You can't see that. But the nice thing is you can see this relationship here, and it's kind of fluctuating back and forth, but it's only a little bit of a glitch in the thing. You can see that the definition is true, that those two distances subtracted from each other are the same value, 2a. And although we can't see this, if I get this as close to 1 as possible, go a little bit over this way. Well, I'm not going to sit and do this for the next 30 minutes, but you can see that this is pretty close actually. It's kind of nice. But I've lost my cursor over there, so that's fine. But you can see that this relationship will stay constant, which is kind of cool. And it's 2 times the distance of the center to the vertices. Okay, so let's go back to the notes.
Okay, so let's look at the equations and the graphs, and these are some really nice pictures that kind of explain all the pieces and parts. And you may have noticed that hyperbolas have asymptotes. Okay, and these asymptotes are created by this box with dimensions 2a by 2b. And it kind of changes based on what's going on. Everything's labeled in these pictures. You should look over them, see if you see anything cool, all that fun kind of stuff. But notice that the distance A and B is not dependent on a direction. The distance A and B depends on the type of hyperbola that it is. So some of them open left, right, some of them open up, down. It depends on the way the equation's set up. So you have a horizontal hyperbola, one that opens left, right, if your x squared term is positive. If the y squared term is positive, it's a up-down hyperbola, okay? Two different things, all right? It's very important that you guys remember that the a squared is always with the positive term, and the b squared is always with the negative term. If y is negative, it's horizontal, b squared underneath it. If x is negative, it's vertical, b squared is still underneath it. A squared and b squared are not attached to x or y. Okay, so your vertices, foci, those are kind of the same thing that we've been doing. Nothing special there. The only thing that's unique is your asymptote. Okay, so your asymptotes have equations that are based on the location of the center, and then also the ratio of b over a or a over b. And this kind of makes sense because if you look at the picture, if my asymptote is right here, so this is my asymptote right here, the rise is going to be b, and the run is going to be a. So b over a is my rise over run. And then same thing over here. If I look at my asymptote here, the rise is a, and then the run is going to be this distance b. Okay, so it flips depending on that orientation. And then this time our relationship between a, b, and c is that c squared is equal to a squared plus b squared. Okay, so it's back to a Pythagorean theorem, which is really, really important that you don't get this confused with the ellipse relationship. There's a lot going on with this.
So one of the reasons why I like hyperbolas so much is because they're very close to a hyperbole, which is derived from the Greek word meaning overcasting. It's a figure of speech that involves exaggeration of ideas for the sake of emphasis. And I do this a lot. I'm not going to lie. I will tell you guys, it's been ages since I've seen you. And all that kind of stuff. It's one of my favorite things to do, and I really over exaggerate a lot of things. It's kind of funny. And that's why one of the reasons hyperbolas are my favorite mathematical thing. It's because they're so close to hyperbole. You can see all these examples. Just a regular Paul Bunyan, you guys. Just a regular Paul Bunyan.
All right, let's look at some examples where we're graphing hyperbolas. So when you graph a hyperbola, you want to do the same thing we've been doing. Find A, find B, maybe find C, find the center. Okay, for this parabola here, not parabola, hyperbola, we have a center of 0, 0, because there's no left or right transformations. All right, now I look at this and I see, okay, x squared, y squared is negative. Okay, if the y squared is negative, it opens left and right. And then I know my a is always the first. Square root of 16 is 4. And my b is the second. That's going to be 5. Okay, so your a and b, a does not have to be bigger than b, which is really important. Then you have to think, well, what's c going to be? Well, c is always a squared plus b squared, so 16 plus 25 is 41. Take the square root of that, you end up with the square root of 41. So c is the square root of 41. Okay, with that information, we have to figure out where our foci are. Knowing our formulas from up here, my foci are going to be h plus or minus c comma k. So that's going to be my foci are at the square root of 41. So add c to 0, you get square root of 41 comma 0, k is 0, and then you have negative square root of 41 comma 0. Okay, and then graphing these is a little bit tricky. Okay, plot your center, and then we're going to draw that box. Okay, remember it's horizontal, so A is my left-right distance. So I'm going to go over 4 this way, over 4 this way, and then I'm going to go up 5 because that's my B distance. And this gives me this box right here. And the nice thing is, my asymptotes are just going to be my diagonals. Okay, so my asymptotes are my diagonals here. So let's do this in, we can probably do it in red. This right here is an asymptote. And then this right here is also an asymptote. And then to actually graph this, you start at the vertex and leave it and go towards the asymptote. Start at the vertex, leave it, go towards the asymptote. Same thing over here, same thing over here. They're kind of interesting to graph. It's a little bit fun. Okay, and then we just have to write down our equations of our asymptotes. And if you scroll up above, you should see that your asymptotes are plus or minus b over a times x minus h plus k. All right, so take the ratio of b over a, so we can do our plus minus. So y equals plus or minus b over a, so 5 over 4, and then x, but minus 0, and then plus 0, so we're just going to put x. There's the equation of our asymptote there. All right, next problem. Okay, first things first, a equals 16, b equals 9. Just go in order, don't worry about anything else. And then we need c. 16 plus 9 is 25, so that means c is 5. Oh, I forgot to take the square root. So a isn't 16, a is 4, and b is 3. So 3, 4, 5 triangle is going to be in here somewhere. All right, so we got this shape now. We see the x squared is negative, which means it's going to open up and down. And my center is going to be 2, comma, well, not 2 comma negative 1. Now, notice how the y is in there. I'm mixing it up already, which is a bad thing for you guys to do as well. Make sure you say it's negative 1 comma 2. Okay. Then we want to add and subtract our foci. So we're going to add and subtract to the y value of our center this time. So my foci are at negative 1 comma add 5 to get 7. And then I got negative 1 comma subtract 5 to get negative 3. Those are my two foci there. And then my asymptotes, well, if this was b over a, this one's going to be a over b, so it's plus or minus a over b, so 4 over 3 times x plus 1 plus 2. There's our asymptotes right there, and this is equal to y. All right, then to go through and graph, you just do the same thing you did before. Put a point as the center, so my center is negative 1, 2. And then you got to draw your box. Remember the a distance this time is vertical, so we go up 4, right 3. Let me get a box that looks somewhat like this. It's very precise. We go through and draw in our asymptotes, which looks something like this. It's a real exact science. And then you go through and let's plot our vertices. Oh, nope, it's vertical, so it's right here and right here. Just ignore that I put a vertex right there. And then we open upwards like this and downwards like this. And that's good enough. Okay, let's run through writing equations in standard form. I'm not going to graph these because that's kind of boring for you guys to watch. Okay, so if you're given an equation like this, notice how there's no x term or y term, only your squared terms. So you're just going to move 225 over. So you got negative 25x squared plus 9y squared is equal to 225. We're going to divide everything by 225. So I end up with negative x squared over 9 plus y squared over 25 is equal to 1. And then we just want to rearrange these so they're in the correct form. Y squared over 25 minus x squared over 9 equals 1. All right, this next problem, you're going to have to complete the square. I like to group everything together first, so I get x squared minus 10x, leave a space. I'm going to put a minus 4, and I'm going to take that out because I know I need this term, the a value, to be 1. And then 32 divided by negative 4 is negative 8, so I got negative 8y. Leave a space, and then this is equal to 103. All right, to complete this square, I'm going to add 25. And then to complete this square, I'm going to add 16. And then 16 times negative 4 gives me negative 64. So I'm going to subtract 64 over there. And I'm going to end up with x minus 5 quantity squared minus 4 times y minus 4 quantity squared is equal to, so that's 128 minus 64, so just 64. Divide everything by 64 and simplify. End up with x minus 5 quantity squared divided by 64 minus y minus 4 quantity squared divided by 16. This is all equal to 1. Right, there's our answer right there. A little bit of work, but not really that bad if you know how to complete the square. All right, our next set of examples is writing the equation of the hyperbola given the characteristics. Okay, this is the same thing as with an ellipse. You need to know three things. You need to know A, you need to know B, and you need to know the center. Okay, so A is equal to, B is equal to, and then you got to see the center. Well, for all of these, the center is at 0, 0. So right up here, given center is 0, 0. You guys know what that means. Okay, I should probably fix that. Let's just fix that real quick. Now I could edit this video, but I'm not going to because everyone makes mistakes. Okay, so if I know the foci is -7, and I know the vertices are at 5, and my center is at 0, 0, I know that A is the distance between 0 and the vertices, so A is just 5. But that foci distance isn't B, it's actually C, so C is 7. So I know then that 49, C squared, is equal to 25, or A squared, plus B squared. If you remember from the ellipses, I don't need to find B, I just need to find B squared to write the equation. So that gives me that B squared is equal to 24. Once I have B squared, and I know A squared is equal to 25, I literally wrote 25 instead of 24, even though I said 24. It's very concerning. So I got A squared and B squared right there. So therefore my equation, because it opens up and down, no, it opens left and right. Because it opens left and right, is going to be x squared over 25 minus y squared divided by 24, which is equal to 1. All right, number 6. It says the foci are at 0 and plus or minus 10, and the vertices are at 0 plus or minus 6. Okay, this is an up and down one instead, but it gives me the same things. It still gives me A is 6, and B is equal to something, and C is equal to 10. And knowing that information, I know 100 is equal to 36 plus B squared, which means B squared must be 64. And A squared is equal to 36. And I know it's up and down, so y squared comes first. And then underneath that goes a squared, which is 36, and then minus x squared over 64. Remember that b can be bigger than a. It's really important that you guys don't get confused with that. All right, next problem. It says transverse axis is vertical, which means this is a vertical parabola. So I know it's going, not parabola, hyperbola. So it's going to be y squared minus x squared divided by a squared and b squared is equal to 1 because my center is still at 0, 0. And if the vertical axis is 18 units, that means that a is equal to 9, which means that a squared is 81. And if the central rectangle is 18 by 22 units, this 22 units is 2b. So that means b is 11, which gives me 121 down here when you square it. All right, for number 8, it says the perimeter of the central rectangle is 20 units. The vertices are at 4, 0 and -4, 0. So if the vertices are at 4, 0, that means a is equal to 4. And if no a is 4, then I know my perimeter is equal to 2 times a plus b. So I got 20 is equal to 2 times 4 plus b. And some simple math here tells me that b is equal to 6. If I know a, I know b, and I know my center, I know it's going to be x squared divided by 16 minus y squared divided by 36 is equal to 1. And I know that the x squared comes first because my vertices have a value in the x position. I have a k value, if you will. All right, so 9 says distance from the center of the hyperbola to a focus squared is equal to 50. Well, that's telling me c squared is equal to 50 because c is the distance from the center of a hyperbola to the focus. And then the endpoints of the transverse axis are at 0 times comma, square root of 20, and 0, square root of negative 20. Well, square root of 20 then has to be a, which means that a squared is equal to 20. So let's write that over here. So if I know a squared is 50, a squared is 20 and c squared is 50, that means b squared has to be 50 minus 20, which is 30. So now I know a squared, I know b squared, I can write my equation. I know the transverse axis is vertical, so y squared comes first. So I got y squared divided by a squared minus x squared divided by b squared. And that's all I've got for you today. Good luck on the IXL assignments, and if you guys have trouble, don't hesitate to stop in to the office hours. I'll probably help you really, really well.